Okay, experimental probability. It's just probability that's based on experimental data or observation. So before, when you were finding probability, some of it actually may have been the result of experimental probability, but sometimes we just figure out the probability based on how many of something there are. So if we want to know the probability that we're going to roll a 4 on a die, we know that there's 6 choices. One of them is a 4, so that probability would be 1 out of 6. That's called theoretical probability. That's what we expect it to be. Experimental probability would be if you rolled that die a whole bunch of times and counted up how many times you actually got a 4, that's experimental probability. So the formula for this is similar. The formula is that the probability of an event is the number of times your event occurs divided by the total number of trials. You find it the same way that you find theoretical probability, except that we're using results from an experiment. So on our example, finding experimental probability, you attempt 16 free throws in a basketball game. Your results are shown. What is the experimental probability of making a free throw? So we need the number of times the event occurs over the total number of trials. How many times do they actually make a free throw here? Olivia? The 1 stands for making free throw. So how many times were actual successful free throws? 8. So we have 8 divided by, Gretchen, how many total attempts were there? 16. So we have 8 divided by 16, and that reduces to 1/2. So the probability is 1/2, or about 50%. Any questions about that? Okay, let's move on to the next problem. This one's slightly different. A bicycle company checks a random sample of bikes. Out of the 400 bikes that were checked, 12 were defective. If the trend continues, which is the best prediction of the number of defective bikes in a batch of 1,300? Now, back when we were doing ratio and proportion, we did problems like this. I think they dealt with actual defective things. So don't think about this as much in terms of probability as how would you set this up as a proportion? If 12 out of 400 are defective, we need to find out how many are defective out of 1,300. I'm going to take a volunteer on this. Anyone tell me how you might set this up? Dan? Uh-huh. Good. Good. So we have how many were defective out of the total as our proportion, and then we're just going to solve the proportion. So this is experimental probability because someone checked the actual bikes. We know that 12 out of 400 were defective, but now we're going to find the total. We also did this in the last section where we did when we did data and we made inferences about a population. That's what we're doing here. We're using probability to make an inference about the population. Lacey, can you tell me how I would solve this proportion?
12 times 12 times 1,300.
Okay, 12 times 1,300.
Divided
Okay, let me write it out first as an equation. I'm going to be dividing by 400, but let me write it out as 400x. So I'm going to be multiplying these two numbers and then dividing by 400. So 12 times 1,300. 12 times 1,300 equals 15,600. And then I'm going to divide both sides by 400. And some of you are good at solving proportions. You don't need to write it all out. You can just kind of skip to it. What will x equal? Anyone have this? Sophia?
39.
39. Good. X equals 39. So we're predicting that there are going to be 39 defective bikes in a batch of 1,300. Okay, next I want you to try this one. Using the same data, predict the number of defective bikes in a batch of 3,500. If you're trying this at home, this would be a good time to press pause and try it on your own before we compare the solution. Okay, Liz, can you tell me how you would set up the proportion for this one?
I made 12 and 4 by 3 equals
X over what?
3,000.
Good, so we're setting it up the same way, but the amount of the population that we're predicting is different. What did you get as an answer?
I got 105 books.
Good, 105 bikes. Question?
I did a different one, but I still got the same answer.
Okay.
I did 39 over 1,300. And then I did X over. I did 39.
Oh, okay, so you use the other portion, that works out fine to do that too. Okay, any questions about this? Okay. All right, I'm ready to move on. All right, sometimes we use simulations to find experimental probabilities. So an example, find the experimental probability that 2 of 3 children in a family are girls. Assume that girls and boys are equally likely. Now we could just pick out a bunch of families and we could get experimental probability that way, but another kind of an easier way to do it quickly is to use a simulation. So we need to use something that we can kind of pretend is the families here. We need to use something that has 2 outcomes because it's boy or girl. Can anyone think of something that we use, like we could have cards, we could have dice, we could have coins. What could I use that has 2 outcomes? Lacey? A coin. I could use a coin. Now I need to represent 3 children. So this coin is going to tell me if it's boy or girl. I'm going to make heads be a girl, and I'm going to make tails be a boy. So I'm going to flip a coin to tell if I need a girl or a boy. How many coins am I going to need? How many children am I trying to figure out? 3. Yeah, so those of you who are showing me 3 fingers, that's right. I'm going to use 3 coins. So the results shown down here are the results someone actually got from flipping 3 coins. So they flipped 3 coins. This TTH means they got tails on the first coin, tails on the second coin, heads on the first coin. So in this pretend family, we've got boy, boy, girl, because it's tail, tail, head. Okay? It asks, what is the experimental probability that all 3 children are boys? So I want you to go through. Oh, I'm sorry, wait a second. We need to go back up to this one. Find the experimental probability that 2 of 3 children in a family are girls. So we're going to go through, we're going to circle all the situations where we have 2 girls. So let's see, I'll use this color. So in this example, we have 2 heads, so we have 2 girls. So any example that has 2 heads had 2 girls. This one's not it. This one has 2 heads. This one has 2 heads. It says it's 2 out of 3, so we can't use 3 out of 3. Use this one. 2 heads. 2 heads. Okay, did I get them all? We don't want to use the 3 heads. It should really say that exactly 2 out of 3 are girls. The third is a boy, so we can't use all 3 girls. Okay, so how many do I have? How many do I have that fit the criteria? Sophia? 6. 1, 2, 3, 4, 5, 6. So I have 6 out of, how many times did someone flip the coins? Emma, how many times did someone flip the coins?
20.
20. So we have 6 out of 20, which reduces to 3 out of 10. Okay, now let's go down to this question. What is the experimental probability that all 3 children are boys? So how many instances do we have up there? Take a second and look through your results. how many of those show that all 3 children are boys? Lacey? Once. It only happens once. The boy happens right here where we had 3 tails. So the experimental probability that all 3 children are boys is 1 out of 20. What about the experimental probability that all 3 are girls? How did that come out? Gretchen?
3 out of 20?
Yeah, it looks like 3. So we have a heads, heads, heads here. And a heads, heads, heads here. I think that's all of them. So 3 out of 20 would be girls. Do you think that that's true? Do you think it's the same that in theory, if we did theoretical probability, do you think that 1 out of 20 would be boys and 3 out of 20 would be girls? Is that realistic? Yep. Gabby's shaking her head. No, why not? What would you expect it to be? Yeah, but if you consider the fact that girls and boys, the chance of getting either is equal, right? So you would think the chance of getting 3 girls would be about the same as the chance of getting 3 boys. But sometimes when we do experimental probability, we don't get an answer close to what we would expect. What can we do to improve our chances of getting a good experimental probability? Any ideas? What can we do to improve our chances of getting a probability that's more like the theoretical probability? Any ideas? Do you think it would be more accurate if we did more trials? Yeah, the more we do, we talked about this a little bit in the data section, the more that we do, the more people that we sampled, remember for random samples and such, the more accurate our results going to be, and the same thing is true with the probability. Okay, your assignment is very short, but you have something that we're going to do in class today also. The assignment is in your textbook, page 349, 6 through 21. It doesn't take very long to do that.